Okay, guys, so we're talking about fluids still. Still having issues with video software, but we'll see if this works now because I've turned down my video settings. Sorry you can't watch this in HD. So if we look at solid water, ice, you can see that they don't really move around a lot. They wiggle like I said they would, but they don't individually like switch places. This guy is always next to this guy, who's next to this guy, and there's a chain, right? Or a lattice is a better way of saying it. And you can see it's true for other things too. Like you get a real nice cube for oxygen, argon, neon. But as we increase the temperature, you can see it around 273 Kelvin. That you can say hi to my dog, Cicero. Cicero, good boy, good quiet. Thank you for telling me. Okay. You can see that as I increase the temperature to around 273 Kelvin, all of a sudden there it goes. The lattice breaks down. Let's see if we can go back the other way. And it start to form that lattice again. So as I cross that boundary, it breaks down. They start to spin more individually. Now it's important to remember this isn't the world's best simulation. I mean, we're talking maybe 70, 100 particles here. Whereas in 18 grams of water, you have 6 times 10 to the 23 particles. So a lot fewer here. You've never seen this few particles and tried to get to actually look at properties. But as I increase the temperature more, I'm going to do it a little faster. You're going to see it start to behave a little bit more water-like. You're going to see them switch places and flow around each other some. Ooh, too much. So you can see they start to switch places and flow around each other a little bit more. And they're not just bound to one spot. So like how much it does this might not be a great simulation for, but the idea is that they're not fixed in a spot. They get a spin, they get to move around. Some of them get kicked out into a gas already. And as I boil this sucker and turn it into only a gas, let's get it just real hot. There we go. That's looking pretty good. You can see that the particles don't really stick together very much. They spread out pretty much as possible, and they just move all over the container. So that's the big difference. So if we look at the properties of a solid, liquid, and gas, it's going to be kind of like you learned in elementary school. In a gas, if you put it in a balloon, it's going to fill the whole balloon. Right? You put it in, whatever you put in is going to fill that whole thing, every little bit it can find. It's going to spread itself out as much as possible. It's going to be very low density. Now, a liquid, on the other hand, is going to stick to the bottom of whatever you put it in. You put it in a glass, it's going to stick to the bottom of the glass, but it's going to change shape to meet the shape of the glass, to match the shape of the glass. And it can still flow and move around, but it's always going to be at the bottom. It's going to be a little bit bound to each other. Way less than a solid, though. Now, in a solid, if you put a rock in a bucket, it's just a rock in a bucket. It's not going to change its shape. So, I mean, you know what the properties of solids are. It's going to sit there. So I think that's going to end it for this video, guys. And I hope it was helpful because this is the 3rd or 4th time I've done it. So, yeah, I'm hoping that's the last. All right, I'll see you in the next video, guys.